Okay, the topic of our lecture is files. And the first half of this lesson, we review the input-output operations. Of course, you use input-output operations every week at every practice. You should input some information and output the result of your the results that is computed by your program. But let's review some features of this input and output operations. And the goal of this part of the lecture is to understand how to work with standard input-output in C++ and some new features of input-output operations. These features maybe will be useful for you, and it's also will be useful when we work with files. One of the subjects of programming languages is to work with external devices. In general, all the computer devices can be divided in two main groups: external device and internal device. Such external device, the example of external device may be a keyboard, screen, and also file. And during this lecture, we will talk about the following questions: how to store information on your hard disk drive, or how to write the file, how to write information to the file, and how to read information from the hard disk drive, or how to read information from the file. We start from a definition. What is file? This definition is not strict. There are a lot of other definitions, but from the point of view of informatics, a file, computer file, is a block of arbitrary information which is available to a computer program and is stored on some kind of durable storage. For example, hard disk drive on your computer, or it may be flash drive, or CD drive, or some other device. There are a lot of external devices that can be used for storing files. A file is durable in the sense that it remains available for program to use after the current program has finished. So when you create, for example, an array, or when you declare a variable in your program, and when you assign some values to these variables or arrays, these values are eliminated when the program is closed. but file is not. The information that is stored in the file remains available when you run the program for the next time. In fact, working with such external device as a hard disk drive is similar to working with your screen with display. This situation is usual for all programming languages, not only for C and C++. All the languages like Pascal, Java, Python can work with files, and this work is very similar to work with the screen and the keyboard. That's why input-output operations, usual input-output operations, are very important. And the first topic of this lecture is to make a short review of input-output operations. Well, we consider how to input data from the keyboard and how to output data to the screen. In C and C++, there are two types of such input-output operations. In C, these input-output operations are called formatted input-output. In C++, it's called streaming input-output. In clear C programs, to input and output information, to input it from the keyboard and to output it to the screen, we use the function scanf to input and printf to output. But these functions are rather complex, and it can be used only in C. And more convenient way is to use the streaming input-output in C++ by means of input and output streams, cin and cout. But if you will write the program in clear C language, cin and cout are not available. In this case, you must use printf and scanf. Let's review cin and cout. There are two types of stream, input stream and output stream. Usual input stream inputs data from the keyboard, and output stream outputs data to the screen display. And cin is identifier for input stream, cout identifier for output stream. This operation is used with cin, this operation is used with cout. Of course, you will, I think you know it because you use cin and cout every lesson, but just to remind you these main points, and after that we consider some important features of cin and cout. This is a general statement of cin. We type identifier of a stream, then we type their sign of input operation and an identifier of a variable number 1, variable number 2, and so on, variable number n. A lot of variables. It can be written here. It can be written here. And some examples. Very simple example how to input the values of variable a, two variables a and b, and so on. These usual statements include IOStream and using namespaces today. Of course, you will use it every week. And the general form of cout, you type output, the identifier of output stream, and sign of output operation, and identifiers of variables, or it's not written very good. It may be not only identifiers of variables, but also the expressions. So it's better to maybe to write here not variable but expression, because expression can consist of different variables. Well, let's know how it works in Visual Studio. For example, int a equals to 1, b equals 2, and cout. Right here, a, it's identifier of a variable, or I can write here expression a plus b, and in this case we will see on the screen the result of operation a plus b. Moreover, I can write here a constants 1 plus 2, no variables, only constants. Cin statements, I can write only variables. Cin A, Cin B. Well, and here I want to show you some feature related with the input and output statements. Suppose I write one input statement here, after that output statement, something like this, 1 plus 2 equals 2. 1 plus 2. And after that, another input statement for the variable b, and after that, the output statement for a plus b. Of course, it's an extremely simple program, very simple program, but pay attention that I write here one input statement, one output, and after that, one input statement. Let's run this program. Let's input A2. After that, we will see on the screen this line 1 plus 2. After that, B, and we see A plus B equals to 5. Well, but what happens? How do you think if I type here 3 like this? Please see that here
Okay.
I input only one variable, A.
You get an unpredictable result.
In
Like
this
a
case,
random numbers.
of course, this situation is not standard situation, but in this case, if I input several variables separated with a space in one line, in this case, their input statement cin reads only the first variable from the buffer, and it store all other variables in some temporary buffer. After that, it carried out the output operation and read the next variable when the program will carry out next input operation. So if I type here two variables, I will see 1 plus 2 equals to 3. After that, this input statement will be carried out automatically. These 3 will be read from the buffer. And after that, we will see this output statement. In this case, I can type here even more than one variable. For example, 7 numbers, 1, 2, 3, 4, 5. But I will read from their input buffer only 2 of them, 1 and 2. All other variables will be stored, all other values will be stored in temporary input buffer, and it will be read later when you write some input statement in your program. Again, let me repeat that this situation, of course, it's not usual, but sometimes this situation happens when we work with files. When we work with keyboard, of course, if we should input only one variable, it's better to input, of course, only one variable. Then the value of another variable, and after that see the result. Well, is it clear?
Yes, sir. Yes.
Well, and maybe the next feature that I cannot. It's only a feature. It's please not use. Well, okay. Oh, yeah, it doesn't work. It works in clear C language, not with C. Okay, we cannot use here constants in cin statements. Only variables. Only variables. In cout, we can use a constant expression or constants. Okay, let's come back to the presentation. Oh, yeah, it's a very simple example, more or less the same as I already show you in Visual Studio how to declare several variables and input and output the values of these variables. Well, let's consider some features of input and output operations. when we output some value to the screen, the output statement cout, it computes the width. It means the number of signs on the screen, the number of positions on the screen automatically. But we can specify their width for one next output operation using the operation, the function width, cout point width, and new value of the width in brackets.
Is to reduce it?
Well, I show you how it works in Visual Studio. Suppose I want to output to the screen some values of I from 0 or from 1, it doesn't matter. I smaller than 20, I++. Out I. What will we see on the screen now? We will see the numbers from 1 to 20. These numbers will be placed in one column.
Yeah, but don't you need brackets? Oh.
Yeah,
Like,
just from 1 to 20, and these numbers will be aligned to left. The output statement automatically determines the number of positions to which these numbers should be output.
Well, I thought you needed curly braces after for loops.
Braces, or I can write it, but as far as I use only one operation now.
Okay.
Well, now width, cout width, and let's put here 5. It means that any number now will be output to the screen in 5 positions. If this number occupies smaller than 5 positions, the first positions, the first signs will be empty. You see that this first one now is written as 1, and before it 4 empty spaces. 4.
Yes.
Let's now move these out widths inside loop, and as written here, this operation acts only for one next output operation. So I specify width 5 for one next output operation. Well, now you see that all of the numbers are placed in one column, 5 positions on the screen.
Yeah.
The next important feature, we can get and set precision for real numbers. Suppose that I want to output to the screen a real number. How many digits after decimal point will be output to the screen? By default, Visual Studio determines the number of digits after decimal point automatically. But we can specify it using the statement cout point precision. Precision means the number of digits after decimal point. Now to show you this example, let's do the follows. Let I be double variable, not integer, but double, real number, and let's output, or maybe let it be integer from 1 to 20. But let's output to the screen not I, but 1 over I. Okay. Let's comment these widths. 1 over I. Could you guess what we see? What will we see on the screen now? If I write it exactly like this.
I guess I don't know, because you put int, but then you put a fraction.
Yes, yes. It's a hard question because I use here int. 1 over I when 1 and I are integers. We will see on the screen 1 and all other numbers will be zeros.
Oh.
1 and all other numbers will be zeros. It's integer part of the division. To see on the screen the real number, I should specify that I should stress that this one is a real one, not integer. And to indicate it, I must write 1.0. 1, just 1, is considered as integer value, integer number. 1.0, well,
okay.
We will see on the screen the fractions 1 over I, 1 over I, and you see that this 1 over I will have different number of digits after decimal point. Here 1, here 2, here 6. Visual Studio decides it automatically. And if the number of digits is greater than 7, it's not show you these digits. But we remember that data type double has 15 digits after decimal point. Cout point precision. Let's fix the precision 15. Now the output statement will show 15 digits after decimal point. Yeah?
Oh, okay. Yeah.
15 digits. If the number of digits is less, if all other digits are zeros, we will not see it. But if these digits are not zero, we will see 15 digits. So precision, let's hear up to 30, for example. Precision regulates how many numbers, how many digits we will see on the screen after decimal point. Well, okay, it's just some features of input and output statements. Maybe let's briefly just let me show you one more feature of working with numbers, and after that we will consider files. To set the precision, we also can apply this statement. We can use cout point precision or cout set precision, but to use set precision, we should include additional input, additional include file io manip. For example, 10. Now we will see 10 digits after decimal point for all the numbers. And out fixed, we will see the real numbers with a fixed point, like we see it right now. Yeah, but fixed shows all the digits, including zeros.
Yes.
Okay. And another option is to use not fixed but scientific. In this case, we will see the numbers in so-called scientific notation. Scientific notation means that we will see the numbers as mantissa times 10 power this number. So this symbol E means 10 power minus 1, 10 power minus 2, and so on. When we work with very large numbers or very small numbers, scientific notation is more correct, more convenient in comparison with a fixed form of real numbers. Well, it's just some features of input-output statements. And I think these features will be useful when we will work with files, when we input some information to a file, read some information from the file, or write some information to the files. Or maybe the last feature, we can output the integer numbers in different system of notation: decimal, octal, or hexadecimal. Again, it's just a feature that I think you will never use, but just as example, let's use hexadecimal form of notation. And now we will see on the screen all the numbers from 1 to 30, but not in decimal form, in hexadecimal form. Yeah, we will see 1, 2, 3, 4, 5 up to 9. Then the digits A, B, C, D, F. Then 10, 11, 12, and so on. 19, 1A, 1B, 1C, 1D, and so on. So we will see the same numbers, but in different form of notation, different notation, hexadecimal. Of course, it's just some feature, and I think you will never use it. You will use the usual form of the numbers, decimal numbers, to output integer values. Okay. This is the last feature that I want to show you. There are some more features, but let's skip it. Let's skip it and let's let me open the next presentation, the next part of our lesson. Now, let's consider how to work with files. The second part, second half of our lesson, how to work with files. It's just this slide is from the previous file. Yeah, let me repeat that. When we work with external device, it's very similar to working with input-output statements. Well, what is file? What is file that is written on a hard disk drive? For example, I can open the file that contains the text of the program, and this file can be opened in Visual Studio, and we will see this file like this. It can be opened, for example, in Notepad++, and we will see this file like this, or I can open it just in Notepad, and we will see it like this, but it still be the same text file. The same text file, but we will open it in different programs. But what is a file at a lower level? At a lower level, the operating system consider the file just as a one-dimensional sequence of bytes. And when this file is a text file, each byte will correspond to the code of the symbol. But at a higher level, the content of the file is being considered, and these bytes, these binary digits, may represent integer values, text characters, or something else. Again, let me repeat that it depends on the program that uses the file to understand the meaning and internal layout of the information. For example, suppose that there are 4 bytes in this file, just 4 bytes. But these 4 bytes may be interpreted as 4 different characters. This is the first way. These 4 bytes can be interpreted as one integer number, because one integer number occupies 4 bytes in memory. These 4 bytes can be interpreted as one real number of a type float, and so on. For example, if we have 8 bytes, these 8 bytes may be interpreted as 2 integer numbers, 2 float numbers, or one number of a type double, or 8 characters. So it depends on the program how to interpret the bytes that that are stored in the file. Well, when we work with files, the general attribute of a file is a file name. Again, it's hard to give a strict definition of what is a file name, but usually file name is a special kind of string that used to identify a file stored in your file system. Full file name includes several components. Their identifier of device, directory, or path, their name of the file, and type of the file, extension. For example, the full file name can look like this: D, thesis PDF. D, this number, this sign identifies the device, the folder. Thesis is the name of the file, and PDF is an extension. Many operating systems, including Windows, allow a file name extension that consists of one or more characters following in the last part of the file name. So usually the file name is divided in two groups, in two parts: the base name and the extension. And their extension usually consists of 3 or 4 characters. For example, txt is a text file, CPP is an extension that corresponds to program written in C++, and there are many other extensions. Well, but from the point of view of C and C++, all the files can be divided into groups: text files, the files for storing text information, and binary files, the files for storing any type of information. In fact, we may use the binary files to store text, but it's unusual. This file, .cpp, is a text file. It means that it includes text information, plain text. For example, the file with extension PPT, PowerPoint presentation, is not a text file because it stored information in some special format that can be read only by PowerPoint. And when we work with files, the following operations are typical in different operating systems. Opening or creating a file to use its contents, reading or updating the contents of the file, committing updated contents to durable storage, and closing the file, thereby losing access until it is opened again. These 4 types of operations are general operations that we can carry out with files. To work with files, in C++, we should write the include statement, include f string. After that, in the main part of the program, we should declare special variable that called file variable. After that, we should open the file. The file can be opened for reading or for writing information. For reading means that the file is stored on hard disk drive and you want to read the information from the file to the program. Writing means that you want to write information from your program to the file. And after that, close the file. So the usual sequence of operations with files looks like this. Declare a file variable, open the file, work with file, and when all the work is done, close the file. Let's look how it can be done in Visual Studio. Some examples is written here in my presentation, but I think it's better to consider the example in Visual Studio. I just copied from this slide. I copy from this slide and I paste it here. Well, or it's array. It's also the array is declared. Okay. Or let it be just 4. And let's declare the array. Well, the example is ready. The example is ready. First, we should declare a special variable, so-called file variable. This variable has a special data type. of stream. That means output file stream. Like cout means the output stream that is connected to the screen. Off stream means the output stream that will be connected later to some file. But after the declaration, file variable is not defined. It's usual situation for all the variables. After that, we should open the file for writing. We should call the function open. f.open and the name of the file.
It's a different file?
In square brackets. Not in square, in parentheses. The name of the file can be specified by programmer. For example, I can give any other extension. And I can write here any file name that I want. The program opens this file for writing. It means that if this file is not exists, this file will be created. But if this file exists, in this case, the contents of this file will be erased, will be cleaned. And after that, I can output the information into this stream, similar to output this information to the screen. Well, here I write the loop, and inside this loop, I output into the file f the elements of the array and a space. After I finish the output, I close the file, f.close. Let's check how it works. First, let's compile this program. We will see that it's okay, no errors. Well, after that, let's look to this folder. This folder contains the solution and project files. And you see that there is no such file, such text file with file name .txt. Now let me run this program. The program is finished, and what will we see here? We will see new file name .txt.
It will be empty. Oh, never mind.
It's not empty. It's not empty because I output to this file the elements from this array 10, 20, 30, and 40. I can output to the file any information that I can output to the screen. For example, I want to output to the screen not the array, but just 100 numbers. How to output to the screen 100 numbers? Just write cout I and a space, right? And the same I can do with file. So do you see that these two lines are very, very similar? This is right to the screen.
Yes, yes.
And
So
this
just
line
press F.
right to the file. Only the difference is the stream. Here I use cout and here I use F.
Okay.
Let's run this program. We will see on the screen the numbers from 0 to 99. Let's check the file. This is a previous file. Because I don't close it, let me close it, open it again, and we will see in the file all the numbers from 0 up to 99. And these numbers will be output in one line. If I write here handle, write here handle 2. In this case, these numbers will be output to the screen in one column. And in the file, we will see the same. We will see 100 numbers. And let's open the file. We will see 100 numbers, one after one, in this in one column. Well, okay, let's do the same with array. Let's do the same with array. For example, let the size 10, and let me write here some other numbers like this, and one more number, 5. 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10 numbers. 10 numbers. Let's output these 10 numbers. And let's output these 10 numbers to the screen. And at the same time to the file. We will see these numbers on the screen, this line, and in this file.
What's the point of the close file?
Well,
line 38.
Sorry,
Okay.
let me finish. And all the information that you output to the screen, you can output it to the file. For example, let's output here the array. And okay, we will see on the screen this message: array with number equals to the value of the array. Let's do the same for the file. Exactly the same can be done here. Run. So we will see on the screen array 0, 1, 2, 3. And in the file, we will see the same. All the information that we can output to the screen, the same information can be written to a file. Okay. Well, any questions about it?
Yeah, I have. It's not really related to what to this specifically, but like in many video games, like computer games, sometimes if there's like, different hacks or different ways to affect the game and the settings in the game, they tell you to open certain text files and change certain texts. Well, if you affect the text from the notepad, Like you open the notepad and you open the file and you change it. Will it change it from the console? Like will it change it also?
Yes. I will show you. I will show you the example how to read information. This is how to write information to a file.
Yeah.
Now let's consider how to read information. Suppose that we want to read information from the file. In this case, we should declare another variable. If stream input file stream and write. After that, we should open the file for reading and read information from the file similar as you read information from the keyboard.
Yeah.
Let's do the same. What we do? Suppose that I have these 10 numbers, and these 10 numbers also is written in this file name point.txt. Then let me delete this array here. Now this array is declared without initialization, but let's read the elements from the elements from the file. What we should do? We should change the file stream, not off stream, but if stream, input file stream. Then we open this file for reading. Then let's read the elements from the file and let's write it to the array. In this case, of course, we should delete end of line. Read from file. Now the elements from the file f will be read to the array. After that, the file can be closed. Now let's output the contents of the array to the screen. After we close the file, cout array I handle. And on the screen, we should see the same. We should see the contents of the file. Let's check. Yeah. 10, 20, 30, 40. Well, now let's change the contents of the file manually. Let's open it in Notepad. And let's put it here 15, 25, 35, 49.
Yes.
13 and so on. File, save. Now the contents of the file is saved here on the hard drive. Now I can run the program and read the new contents from the file.
Okay, they're connected.
Program.
That's cool.
Well, when you work with files, you can store the information. After that, you can close your program, close the computer, turn off the computer, and maybe tomorrow you can open your program again and read the information from the file to your program.
That's what they call durability, right?
Yes.
What if you put letters? I guess if you could only use numbers, right?
Letters.
Yeah,
in this case, we should work not with numerical data types like int or double, but with character data types, char and array of char. The work with array, the work with characters is little bit harder. Let's consider it sometimes later. Today we are talking only about numerical data types.
Okay.
How to store and how to read the numbers from the file. Okay, let's come back to the presentation. Well, let's briefly review what we consider. If you want to write information to a file, you should create the file variable f of a type of string, output file stream. If you want to read information from the file, you should create a variable f of a type if stream, input file stream. And sometimes, in some cases, you can create just f stream, and the type will be specified later. Will it be output or input? Well, and here is two examples. Here we see two examples how to create a general type of file fstream. Here you should specify the name of the file and the type. Will it be output or will it be input?
What are you asking?
Another example, how to create and open the file for read, for output information, and to input, to read information. But usually it's better to write to use a specific type of file variables with predefined properties like offstream or ifstream.
Okay.
Well, and one of the important features of working with files, you see that there are this is a very large presentation, a lot of features. We will not consider all of the features, but just maybe the most important features. The most important features. We can use special specificator append to not to delete the information from the file, but to append new information at the end of the file. But because usually when you create the file just like this, f.open and file name, the file will be rewritten. But if you write here this identifier, iospace append, the file will be opened for appending information to the end of the file. Let me show you how it works in Visual Studio.
What's appending?
I show you the example.
Okay.
Let me go back to the. I just do all the changes and okay, offstream. Well, let's output the information to the file. Let's run this program. Or of course, I forget to here initial values. Well, let's run this program again. We will see these values, and these values will be output to the file. If I run my program again, the contents of the file will be the same. 10, 20, 30, 40, 1, 2, 3, 4, 5, 1, 2, and so on. But let's open now with these identifier iOS. Oh, sorry. iOS base. iOS base append. Let's compile. It's OK. Now let's run the program again, and let's see the difference. On the screen, we will see the same 10, 20, 30, 40. But what happens with the file? We will see the previous contents of the file and new information that is output to the file will be appended to the end of the file. The previous information will not delete it. If I run my program again, so what happens? Yeah. 1, let's run 2 times, 3 times, 4 times. Now let's open the file. You see that their information will be written at the end of the file. It will be appended.
Oh, okay.
So previous contents of the file is not erased, is not cleaned. But if you open the file in usual mode, the file will be cleaned before writing, and you will see only the information that you output to this file in the course of program execution. Well, it's just one more examples. So there are a lot of examples here in this presentation. I will send you this presentation, or maybe this is a good example. What happens if file is not exists? For example, you try to read the information from the file, but there is no such file. How to check it? When you call the function open, or when you just open the files for reading, after that you can check the state of the file.
Oh, if statement. Okay.
If f point fail, it means the file is failed for opening. We just output the message to the screen. Let's check it. Output file stream f, or it may be, it's better to write as input. Input file stream. This. Okay. Let me comment it. And let's open and let's check. If f point fail and write some message. All other statements will be done only when the file is opened correctly. Without no such file, something like this.
Yeah.
The file name .txt now exists. Here is it. Let's delete it. Let me delete it. I delete it. No such file in this directory. Let's run my program. And we will see on the screen this message. No
Yes.
such file. So this if statement allows us to check. Is the file opens correctly or not? If somebody goes wrong, we can output the message to the screen. If everything is okay, we read information from the file. It's better to write return 1. When we write return 0 means no error. When we write return 1, it means something goes wrong. Well, let me repeat that there are a lot of examples here in this presentation. Maybe if we have enough time, we come back to this important topic and we consider some of these examples. Now, let's finish our lesson. I will send you this presentation. You can read all of these examples. Now let's finish.
Okay,
Let's
sir.
finish our lesson. Let me stop recording.